we are going to demonstrate the experiment Planck's constant. So the aim of this experiment is to determine the Planck's constant using LEDs and also calculating that wavelength of IR LED. Okay. So now let us go for apparatus. Well, see here, this is that apparatus are required to perform this experiment. So these are the connecting wires, and see here we required LEDs. See here we are having that different wavelengths of LEDs. Okay, so if you see that here we have red, yellow, green, blue, IR, and in this experiment basically we are focusing to calculate that wavelength of the IR LED, and remaining using that LEDs or red, yellow, green and blue. So we are going to calculate that Planck's constant using these LEDs. And see, another most important thing is, so entire experiment we are performing using that kit. See, every components are assembled inside of the kit. So this is that very easy to perform these experiment sessions. Now let us go for how to connect the circuit, so using the connecting wires. Okay, so first of all, so let us connect the wire that finish using the two connecting wires. You can connect it now. The circuit is on. Okay, the next one is, so here if you observe that in this circuit diagram, it's a very simple circuit, and here we have this is that where you will observe that symbol of LED. This is the most important, everyone please note it down, because so some other times we required this in order to answer that Viva questions also. So they will raise a question, please note it down. So this is that symbol of LED, and so in the inbuilt already, see, they provided resistance, that is 1 kilo ohm, and see here we want to measurement, so we want to measure that corresponding voltage of the LED. So that is connected voltmeter, where it is connected parallel to the LED. Okay, and so to observe that voltmeter readings, so here we had to connect that positive to positive, okay, and negative to negative. That's it. Okay, so because so here we had to measure the potential drop. So that potential drop of the voltage will be observed by connecting a voltmeter across of the LED. Now, so this is that where circuit diagram is completed, and here if you observe this slot is provided for inserting LED, because if you can if you want to insert LED, so in this circuit diagram, so then its LED symbol is not visible. So for that purpose, here they provided one separate slot for inserting LED. Okay, now so let us perform this experiment. Okay, now let's see that what happened. Now I am going to turn on the kit. Okay, once if you turn on the kit, then so let it be stabilized, and then so just insert LED. Okay. See, now once if you inserting LED, so if you observe that, see here is, so that voltage, that new voltage here it showing that 1.36. okay, see here you don't get confused it. So this is also an LED, and if you observe that so it does not emitting light. So why it is not emitting light? Okay, so this LED is IR LED, okay, infrared ray. So infrared ray usually it is beyond that 7,000 angstrom, so that's why it is not visible for us. Okay, and then after that switch off the kit, next remove the LED, okay, and insert another one, okay, then insert another one, and after inserting then switch on. So now see, this is that yellow color, and you had to note down the corresponding voltmeter reading. So you had to wait for stabilize because of that recombination of electrons and holes. It take a time, okay. After stabilizing, so then you had to note down that corresponding reading, okay. Then again to switch off and remove that LED and insert another LED, okay, then switch on. So this is a blue, okay, let it be stabilized sometime. Okay, and where you have to note down that corresponding new voltage. So the new voltage, and once if it is stabilized, then you have to note down that corresponding new voltage. So once if it is done, then switch off and remove that LED. Next, insert one more LED. Okay, then so you are repeating the same procedure, and this is your green. Okay, and you have to note down the corresponding reading. Okay, next switch off and remove that, then again insert one more LED. So this is the final, this is a very red color, and gradually you may also find the important note here. So if the wavelength increases, so corresponding barrier voltage also, corresponding new voltage also decrease. Please everyone, please observe it. And once if you noted this corresponding readings, then switch off and then remove that LEDs, and also remove that connecting wires. Okay. So then you have to calculate calculate that calculate that Planck's constant using those values, and with respect of using the formulae where H equal to EV lambda by C. Okay, so using that we are going to calculate that Planck's constant, and then see your Planck's constant is the Planck's constant is 6.634 into 10 raised minus 34 joules second. Okay, once if you further, and we are going to calculate that wavelength of the IR using these values. So here we are not going to enter the value of wavelength of the IR, and we want to calculate that wavelength of this IR value. Okay, using this Planck's constant. Okay, thank you.